Okay, now that we're doing completing the square and we've used it to solve some equations, um, probably a more practical application is a situation where you have an equation where the leading coefficient isn't 1, where it's a much larger integer, or it could even be a fraction or a decimal or something like that. So we're going to look at how do we deal with that. All right. Let's check out this first problem we got here. So we got 3x squared minus 9x minus 3 equals 21. Well, the first thing I see when I look at this, all right, if I ask you, what do you notice? I hope one of the things that will come up is that you will realize that 3, 9, or sorry, negative 9, negative 3, and 21 all have the number 3 as a factor. So what I would think is, well, let's get 3 out of there. And so you might ask, well, how do I do that? Well, what you do is you're going to divide each side of this equation by 3. Okay, and this side over here is easy. 21 divided by 3 is 7. But over here, you just need to remember that when you divide an entire side of an equation by something, you're actually dividing each term by it. So that 3 gets applied to all 3 of those numbers. And then you just simplify it. So you wind up with x squared minus 3x, and then negative 3 over 3 is negative 1. Okay, so now I've got x squared minus 3x minus 1 equals 7. Okay, so this is, even if I subtract 7 from both sides, I know negative 8 is not factorable, is not going to give me something where I can factor that and do that with this whole trinomial. So I'm going to have to complete the square. All right, and to remember our process for that. So the first thing we do is we get this by itself. Let's add 1 to both sides. So you get 8 over here, and then you get x squared minus 3x. And now the next thing we do is you always divide this term by 2, and then you, then you square it. All right? So let's divide, if I divide negative 3 halves by 2, right? What happens is it stays negative 3 halves. And then when I square it, right? Remember, when you square something, you multiply it by itself. So this would be negative 3 halves, basically times another negative 3 halves, right? Is what you got there, right? So negative 3 times negative 3 gives me 9. 2 times 2 gives me 4. And so I have plus 9/4. And you might be thinking, oh, God, are these all going to be this ugly? And, some of them are and some aren't. So I'm going to add 9/4 to this side, and I'm also adding it to this side because it is a balanced equation. I hope you are understanding that concept by now. And then when you write this out, right, in order to get this to be minus 3x, you would have x minus 3 halves quantity squared is equal to whatever 8 plus 9/4 is. Well, 8, let's write 8 in terms of fourths. So 8 times 4 would be 32/4 plus 9/4, which will give us 41/4. All right? And you're probably thinking, God, this is really, really messy. And you know what? It is a little messy. I'm not going to lie. But you're smart. You can figure this out. So let's take the square root of both sides. Okay? Square root of 41 over 4. Well, I know that the square root of the bottom is going to be 2. So we're going to wind up with square root of 41 over 2. And that is plus and minus. All right, so next, I'm going to take this and I'm going to have x. I'm going to have 2 cases here that I have to solve for. All right, and so my first case, I'm going to do this in a different color. All right, my first case is I'm going to have x I have x minus 3 halves is equal to my positive case. And then I have x minus 3 halves is equal to my negative case. All right, and so then you just you simplify it. It's by adding 3 halves to both sides. So you're going to get x is equal to square root of 41 over 2 plus 3 halves. Well, that's basically the square root of 41 plus 3 over 2 because they have a common denominator. And this one's going to be the same kind of thing, but the difference is going to be you're going to have x is equal to the negative square root of 41 plus 3 over 2. And then what I would recommend is, I don't like the way that looks at all, so I'm going to take a calculator, and I think they usually recommend that you simplify these anyway. So take a calculator and figure out what your square root of 41 is. All right, so the square root of 41, if I put it in, is 6.4, is what the square root of 41 is approximately equal to. So we got 6.4 plus 3, which is 9.4, divided by 2. 9.4 divided by 2, which is approximately 4.7. So that's one of my roots. And then you have square root of 41. So you have negative 6.4 plus 3. So 6.4 minus 3, 3.4 will make that negative. All right, and that is divided by 2, which gives me, oh, that did not work out right. That was a times. What happened there? Let's see. So 6.4 negative plus 3 divided by 2 gives me negative 1.7. Negative 1.7. So my two roots are going to be x is equal to 4.7 or negative 1.7. So these get a little messy, but the basic idea is that you are going to set this up the same way once you've gotten rid of that coefficient that isn't a 1. And you get rid of that by dividing through the fraction like that. And this took quite a while to do, so I'm not going to go entirely through the next lesson or the next problem. I had 2 problems for this, but I just want to show you what your first step would be. So your first step would be just dividing this by what? You want to get this to 1, right? So you would divide this whole thing by 5. All right, and then that gets you to x squared minus 2x, and then you have 23/5, and then at that point, you're going to do your regular completing the square business. All right, kind of going through this quickly. All right, and then you'd have x minus 1 squared is equal, well, 23/5 plus 1 is 28/5, because 1 is 5/5. And then you have x minus 1 is equal to square root of 28/5. And that would be plus and minus. And then you'd have your 2 cases where you have x is equal to 1 plus this number, and you would figure that out in your calculator, or x is equal to 1 minus this number. So same process. It all starts with just seeing that, hey, I got this number in front of the x squared term. I want to complete the square, so I got to get rid of it. So you're going to have to usually start those problems with some division. But it's not too bad. I believe in you guys. You can do this.